This should be going live. I should have taken notes before I start. Today.text. So, today I am going to try and implement this video. So this is TanTan. He's another developer that's doing Rust and Bevy. And he's making a voxel game, and like a year ago he put out this video about his binary meshing algorithm, and someone suggested in one of the other streams that I should implement this as my greedy meshing algorithm, which at the time, like, I wasn't going to go through the effort of implementing. Like, I knew it existed, but it wasn't for what I was trying to do, which I was trying to get something out before the before the Bevy game jam. So I was working with stuff that I knew. Now I want to try and implement this because I was watching the video today because I was bored, and I noticed something that he's doing that I'm like, I think I could make that faster if shaders work the way that I think that I can get them to work. I should be able to cut out a big section of the code where he's like breaking everything down and then meshing each individual block type. Instead, meshing the entire mesh as one mesh, regardless of the block type, and storing the block type as like a 3D texture that I can then reference while I'm decoding the mesh in a shader, and therefore not only will the mesh be smaller because I can combine every block, not just yeah, good luck. I'm gonna need it. So it's not just going to encode all the same blocks. It'll instead mesh all the blocks as if they were the same type, and then while the shader is running, decode what block should actually be inside. So I did have somewhere like a list of things that I need to do. So the first thing is I'm going to port it into my style of doing meshes, which is to not query neighboring meshes. So instead of needing 34 bits, I only need 32 to do 32 by 32 chunks. And that means that I won't use U64s, I'll just use U32s, which I don't know if that'll make a difference because most people are going to be on 64-bit architecture, so it actually may be slower to use U32s. That's something I'll have to benchmark. So I need to first port to my style of chunk. Then we need to benchmark that, because if we don't benchmark that, then we won't know like if the changes that I make outside of porting it to my style are actually having any kind of impact on the shader, on the thing. So then after that, we need to add something. Right. So we need to get each block. And extract or get pipe and build it rep. And then we run binary GreedyMesh on whole chunk. Oops. And then in shader we decode position, normal, and then pass voxel ID to vertex, to fragment, and then in the fragment shader we use vertex ID to sample texture, and then get block, I guess. Right, and then we use sample texture and get block. Then we use block to get UV to sample main picture. Now, I would like to pass the texture that we make while generating the mesh in as like a, not a uniform, but as similar to how like transforms are passed in. So instead of needing a different material for every single chunk, you would be like part of the entity contains the material that represents that block. But sadly, I don't actually know how to do that. The other option is to literally make the texture representation part of the encoding of the block to save even more space, but that seems unnecessary at this point. But the idea is at the moment I'm just going to make a completely separate material that will hold a reference to the texture atlas as well as a reference to the texture that represents all the blocks. So it's going to be much less memory efficient, and you're going to need a different material for every single chunk. But that's the trade-off for this kind of like optimization, I guess, at the moment, because I don't know how to do the other one, and it would probably be a big waste of time to do it anyway. So we probably want to make a new file here and say GreedyMesh. Alright. Okay. Then here we want to go benchmark, do this, and go here and go GreedyMesh. Did I spell that right? Who knows? Yeah, same. Okay, cool. So that then needs the little bit where I somehow macro this thing into existence. Where I need this. Just copy the whole thing. And then go. We're going to destroy this bit. Apparently my thing is not detecting that it exists. Why do you not exist according to this? What have I done wrong? Okay. Don't know what I've done wrong. Am I just not using the right? It's like identical, so I don't actually know. Anyway, let's actually start working on some code. Unless it's just not like it's still building something, so maybe Clippy's doing something. So why does this file not exist either? Okay, weird. So mesh gen. So I kind of want to leave a lot of this stuff, but maybe it's not necessary. I have put it on its own separate branch. If you want to try this stuff, you got to go to the v2 branch, which I guess we'll just start by removing all of this. Cause, yeah, we don't really need it. And then so we're gonna go to the repo and work out how exactly the greedy meshing out worth. Cull mesher, greedy mesher. So let's, I guess, make a module. Maybe we should leave all this stuff and then make a sub module and then work from there. Alright, mod greedy. Mesher. And we do this, we go here, and we go, okay, greedy mesher. And then we do this, and we go work out what exactly we need to change in order to get this work. So a greedy quad is something. I wonder if it's defined in here. Yes, it is. Okay. Which has an X, Y, WH. Okay, cool. Y vertices. Okay. AO. Don't know what AO is, but we'll work that out. So build chunk mesh, which takes in a chunk ref. Right, so I have to look up what chunk reference is. I'm assuming that's just the data, and therefore will be fairly straightforward to deconstruct. So a chunk ref is a chunks, which is a vector to arc chunk data. Okay, so that's literally just the references to the chunk. So this is how it does it. So we're going to say mesh chunk, or chunk mesh, which is defined in chunk mesh, its own separate thing. Chunk mesh, which is just indices and vertices. Okay. Indices and vertices. Okay, so new file. It's going to be called chunk. Let's call mesh. Oh, should I put the RS in the end? Do it. RS. So I paste this in here, which is fairly straightforward, and this is going to be mod chunk. What do I call it? Chunk. Chunk underscore mesh, and then use chunk underscore mesh. I think it's called a chunk mesh. Doesn't actually do anything at the moment, which is fine. This, and then we go, why are you not liking this? Oh, because I put you in the wrong spot. You don't do it here. You go here. So that would be here. And oh, I already did mod apparently. Okay. Mesh. Like so. And then okay. There's public, so you can access to it. Okay. Generate indices. Okay. Make vertex U32. So some of this stuff I'm assuming is duplicate stuff from what I've already got, and it's about packing it efficiently. But rather than trying to decipher everything, we'll just grab it and work that out later. Utils. So is on edge. Okay. So let's work our way from the top. So level of detail. I'm going to drop level of detail because that's going to take too long to implement. Chunk references, build mesh. So chunk references is going to probably end up being just a reference to, I think it's called chunk data. Like so. And okay, so like this, reference chunk data, so then let mesh, and then quads dot extend vertices from face direction. So that's coming from face directions, and right, okay. So like here, mod face direction, and then we have face directions, A and C, here, and go here, and we go back to GreedyMesh, and we go use super face directions, face direct. Okay, so that means we can get rid of this. We got the chunk data, which is coming from somewhere else, but level of detail we got rid of. Utilities, did I copy utilities? No, I guess I have to kind of copy everything because I don't know what any of it does, and I don't really have the time today because I've got dinner plans, so I can't spend forever trying to decipher things. So it's better to copy everything and then see if the improvements that I have planned actually do speed things up. That's the key point here. So, because again, for all I know, this may actually not be any faster. Vect bounds, modular bounds. Okay. So we need to go here. We just go utils. So. Okay, now what are we missing to get you to so GreedyMesh? That's also spelled wrong. Maybe that's why it's not working. Weird. Just okay. So GreedyMesh, so this we've got this exists chunk ref, well it's called chunk. It's called chunk now, and chunk. This is called chunk. I wonder why these are commented out. We'll find out later, I guess. Get rid of this, get rid of this, get rid of this. Then we're going to jump to vertices from face, which again we're just going to drop our level of detail. This can take a reference to chunk data. Chunk data like so, face direction. Okay, so oh, there's ambient occlusion, that's what AO is. Okay, so probably not going to call this one then. That builds it with ambient occlusion. Right, okay, so I guess I don't know how ambient occlusion works. Maybe we'll just comment this out entirely because I'm not going to be able to implement that. So you are a chunk data, or a reference to chunk data. So, and then you are to rename to chunk. So mesh quads, we extract the quads, then mesh vertices extend quad. Okay. Okay, if vertices is empty, none, mesh indices generate indices, mesh generate vertices len. Okay, okay. Generate vertices from the face direction, all planes. Okay, so vertices from face. So this one we're not using because that one is the ambient occlusion version, which commenting that out made that really weird. Okay, so you don't take a level of detail anymore. You take a reference to chunk data, and you can be called the chunk ref if you like. So this is then broken because we have all these levels of detail, which is then going to go in, we're going to go like that. Okay, so I'm assuming that's just going to do what it does, and then apply vertices. I'm assuming, is there an apply vertices without ambient occlusion? Compresses the quad data into input vertices vec. Okay. So pack ambient occlusion strength into vertex. Bits in 1 and 2 and 3 and 3. Oh, what? Make vertex U8. U32, which is this XY level of detail, and times jump. Oh no. This seems like it's that's coming from utilities, which apparently it's because it's not. It's I should just change this to super. Then there is no chunk ref anymore. Then there's chunk data is gone. Voxel mesh block type, meshable block types. Let's go back over here and go meshable block type, which is from inside of voxel, and then we have meshable block type, grass and dirt. Okay, it's an interesting way of doing that. I've got an is solid function, so that'll do the same thing. Okay, so generate indices and this. Okay, so small issue. I don't know how the format works, but the okay. So vertices, faces, no ambient occlusion. So 4 axes. So size is level of detail dot size. So I think in this case we have to replace size with just 32, I guess. Vertices. Okay, so mesh and then blockable mesh types dot yeah. For block type. Okay. Wait, so this chunk refs must be something else, because if it's I must have accidentally clipped something out at some point. Wait, there's one called GreedyMesh optimized. Maybe this is what I need. Yeah, this seems more like what I need. Build chunk mesh, chunk reference. All voxels is the same. Let mute chunk mesh. This seems more like it actually. So that must be the old one. So let's just paste this in and we go, okay. Now we convert this one to working. So build chunk. So this becomes a reference. Okay. I need to check this chunk refs thing and make sure it is just what I think it is, which is a vector to an arc of chunk data. What it was. So build chunk mesh chunk refs. So that was in somewhere chunk refs, and then we go into chunk refs. Chunk ref is an arc to chunk data, which is back chunk. Okay, so look inside of a chunk. Now where's the chunk file? Chunk, and then we go, that just contains a vector of block data, and then a block data comes from where? Voxel block data. So voxel block data. So the block data is just the block type. Okay, so I can immediately just replace this with my chunk data. That one. Okay, so this one, you need to pop out. Let me go home and go use.
Yeah, we're going here.
This can use super then, and then hopefully that'll fix a bunch of the issues. So chunk mesh, it goes to chunk mesh. Okay, chunk refs we're getting rid of, constants, which is chunk size, padding 2, padding 3. Okay, so I need to go check out what these constants are, which I guess is just to see, just grab the whole constants file. Apparently that's a lot of constants. we'll go here, we go new file, constants. I gotta keep remembering to put the RS on the end. I probably also spelled it wrong, but we'll find out. Okay, and then we go here, and we go mod constants. There we go. Okay, GreedyMesh. Alright, so face direction comes from face direction, LOD comes from LOD, which we can get rid of because we're no longer using that. Utility goes from utility. Okay. So, we need to at some point work out where all the LODs. So this is the LOD. Okay. So greedy binary mesh plane, and that takes in data and the level of detail size, which in this case is going to be, I'm assuming, I actually should probably check that the LOD, I would guess is 32 when you're doing a 32. So LOD 32, yeah, okay, so 32 returns 32. So this is, we can just pass 32 in here. So everywhere there's a reference to LED size, I'm going to find every reference to LED size and replace with 32. Okay, and then we're going to find all reference to LED. We're going to go apply vertices, get rid of LED. Jump index. Ooh, jump index is 1. Okay, so jump 1. So this is world to sample LOD. Okay. Well, to sample LED, and okay, so we have to leave those for a second because I have to work out exactly what value I'm passing to them. Okay, well, to sample, we pass in LED, and apparently LED is just never used. It's interesting. Okay. So we can get rid of that, and then we can go face direction, so just don't use that, and then here and we go, okay, so everywhere we find a log the sample, we go Control F, and we go, okay, so you can go, you can go, you can go, you can go, okay, so then we multiply by jump, which is just 1, so I think all these references to jump can go, but you take in block type, which we get as block type. Okay, LAO block type ampersand with a lot of Fs. When is this? 2, 4, so it's 8, 9 Fs. Okay, right. Hence, you then so you take the ambient occlusion and then you shift it 9 bits over. Shift right 9. Okay, right. So you erase the bottom 9 bits, shift it over 9, and then end it with them. That seems backwards, but okay. Q.append vertices with block type. Now, in this particular case, where is block type coming from? Equals. Oh, right. The block type is if we shift the LOD out. So you don't know what it is because you don't know what this is, which is block AO. Which, where did this come from? Data dot into enumerator. Where did data come from? And we set data up here somewhere, I guess. So for axes, the data is here. The data is a hash map or hash map of U32 by U32. Okay, so that probably needs to go. GreedyMesh plane for every for each every axis 6 key block plus AOA. Okay, so I still don't understand why this is getting confused. So we say for data, the data up here is an array of hash maps, right? Which you don't know about for some reason. Why do you not know about it? Because data here is unknown. Wait, what? Is this something you could do in Rust? I didn't think you could. What? That's why it can't work out the type. Nope, it still can't work out. I didn't realize you could declare and then assign later. That would be really goddamn helpful. Something I wish I knew earlier. It's something I've learned today. So wait, this takes something smooth. You're getting confused because you are the wrong type, which actually means I'm going to go fix that because that's a cool little thing. I didn't know that Rust you could like declare and then assign later, which explains why the compiler yells at me all the time about I declare something and never assign to it. Okay, so question is cargo check. Is that everything? No, it very, very much dislikes this. Use of undeclared something. What is Rusty Buzz? Okay. My guess is that this must use something. It's not. What the hell? Let's see what you have in your libs to work out what dependencies I have. TinyVec, Rand, Chacha, Bevy, Inspected UI, Bevy Atmosphere, Bevy Flycam, Bevy Screened Diagnostics. Okay, never heard of that one, but that seems cool. Bracket noise, function light, Rand, okay, TinyVec. So what the hell is crashing and why does it not like it? Found create async task. That's inside async executor. That okay, but is that related to me? I turned off the default features. So let's turn the default features back on. It'll break my crate long term, but short term is fine because. And it's probably just trying to use a bunch of async stuff that like, no, it still doesn't like it. It's a bit weird. Cargo update. Maybe it's something's incorrect in my like lock or my toml or something. Okay, and then can we cd.slash? We should be working in crate boxes. This, let me see, cargo check. So it updated a whole bunch of stuff. Don't know if any of it's related to why it's having this issue, but it's compiling now, so that's a good sign. So let's try and decipher what actually we return. So the GreedyMesh returns a mesh. Who would have guessed? A chunk mesh, which I actually don't know what we do with, but it contains indices and vertices, which I assume the vertices are like tightly packed, like what I'm doing in my shader of like packing the direction and the block type and everything into the same thing. So when do we actually return? So that's what's returned is all the voxels same. Okay. So the mesh is default here. Then we get the mesh. When do we insert into the mesh? Like right at the bottom, we say vertices.extend with mesh.vertices extend with vertices. Okay, and I think that's the only time that we do that. That's okay. May as well just check that before you return. Okay. Anyway, mesh indices is generate indices. Okay. So generating indices, which is the concerning thing about generate indices, is that it implies that vertices are being added in a specific order and orientation, which is not great for me being able to port this quickly. Generator of indices, assuming vertices are made of quads, okay, and counterclockwise oriented. Okay, so I think this is just what my vertices code does, so that's actually should be fine, because all it's doing is assuming that we're adding 3 vertices at a time, and because it does not like whatever I've included somewhere. Something stroke. What crate's doing this? Who knows? Something is not happy. Something multiplying by t, which is alert function, which is coming from RGB. Something is very not happy with what I'm doing here. So you only use Bevy, that's fine. You only use Bevy. Today collections time vec Bevy. So this is super and a bunch of constants, but that's all stuff that I've declared. And then utilities just uses Bevy. So I don't actually know what I have done to break you. What is broken? What crate is not compiling? What the hell? Okay, question. If I go and say like stash all changes, What the hell? Is this something broken with my Rust now? Well, possibly, because I noticed something else the other day when I updated to the latest version of Rust, is it just busted everything, like it is this red lines under everything. But that's still compiled at least. It's going to take a while because it's building WebSys. Okay. Web. Weird. I don't know what's going on with that one. Yeah, the level of detail just stopped, so I assume you didn't fully implement it. That was a bit weird that I got to the end. It's just sort of like, nope, it's gone. Yeah, so I don't know why my Rust is not compiling. Build artifacts. Is it possibly I've got the Bevy like command line thing that like I can call I don't think it's in my terminal anymore. It was like Bevy run web or something. Terminal. It's like cargo Bevy run dash web or something. Is that what it's called? No. Was it just Bevy run web? Oh, okay. No, that's okay. Oh, it's probably dash release is what I was thinking was the dash. Anyway, this is not compiling because something is... Okay. Cargo run. What is broken? Okay, so first off, cd dot okay, and then run. And go, what? This is perfectly fine code the other day, which means that like a crate's broken. Weird. Well, I'm gonna continue trying to work my way through this code while we wait for this to compile. So, right. Oh, to re-go over to a different branch. That's gonna be a bit difficult. We'll look at the changes in here so I can try and decipher some more of the code. So the GreedyMesher, we get empty mesh. That's me. That's my code. So chunk mesher, GreedyMesher. So what do we do? We iterated through everything and then we packed it all into vertices, which means we're storing quads, which is good, I guess. So if B block type is solid, okay, so that we shift in the corresponding okay, it's a three-dimensional array there, but okay. So chunk padding, and then we go this, and we do this, and we go face culling. Come on, hurry up and compile so I can look at this code in a proper editor. So where I want to make my change was, I think the first loop we go through. So when we say build chunk mesh, add voxel to axis column is block. Okay. So you're an array with 3. Okay. U64 by chunk P by chunk P by 3. So I think I can go down to chunk size because I'm not going to do the extra padding, which is fine. Add voxels to axes column. So then you just do 0, 1, 2, your yx, yz, zx, or it equals to 1, shifted A, shift x. Okay, so that's just packing that in there. Then inner chunk voxels, vec3 to index. Okay, this seems horribly inefficient, but okay. So that's a chunk. Okay, for xyz, let I will match voxels.leng 1, 0, otherwise it's this times this. Add voxel to voxels column. Okay. Neighbor chunk voxels. Okay. No, don't can't bother optimizing the, might be worth it though to together. They're almost as long as the entire inner chunk loop. So yeah, well, there's gonna be a bit of a speed up there. I'm gonna rip out the neighbors thing because I don't think neighbors are necessary at the cost. Okay, so it didn't throw up a big bunch of red warnings, which implies that this is fine. Maybe I'm using a feature in here. No, I shouldn't, because I've just got default features, and that could it be that I turned on the Bevy PBR twice, possibly? So it compiles in the old build, which is weird, because then if I go back to here and I go like, hey, can we restore these? You very carefully click restore, because I fucking clicked discard a few times and it really annoys me. So then we want to go run it again and see if it comes up with anything. See if it works this time, I guess is the better question. So we're going to cd.slash voxels. We're going to go cargo check. Why are you building WebSys? That seems unnecessary. Can I get you to stop? Apparently not. How do I get you to stop? Erased it. Okay. Okay. And then it's compiling everything and build artifacts. And does that mean that it's going to not crash horrifically this time? Well, apparently this one got priority, which is fine. This was the game itself, I believe. So it's checking to make sure that the game's still compiled. So it means we can go back to reading this because it's actually going to be like all type hello now. So we insert everything. So what I wanted to do is I want to get rid of this because we don't need the neighboring. So we can get rid of that. And then we can probably replace all instances of padded with this chunk size.
I'm sorry.
All right, so go back to work on this. So we need to go back to chunk size and chunk size and chunk size. And we go. Okay, so now we can do all that as chunk size, and then we have to go find all the other references to chunk size control. So this is the same. So face culling. So this is for axes 0 to 3. So again, I think we go chunk size and chunk size, and then we insert everything into the axes column and do all that fanciness, and then you're a hash map of hash maps, which has to go at some point, and then find faces and build binary planes based on the voxel and AO, etc. So trailing zeros, skip padding by adding 1 for X padding and Z plus 1 for Z padding. Okay. Column face masks. I think I don't need this. I don't know. Skip padding by adding 1 for padding. X for padding. Oh, right. So it's adding 1 to Z and 1 to X because it's skipping the padding, which we don't want to do because we're not skipping the padding. So we get the column and then we shift chunk size. Yep. And then we what? So apparently 33 okay, so something here, I'm passing something and it's saying 33 pattern 0 to 30 or equal to 1 and 33 max not covered. Okay. Oh, because I'm matching on something, that's what's causing it to not like that. So GreedyMesh plane, so I was passing in, well apparently I called this 32, which is actually supposed to be called LED. Which then I don't think was actually used anyway. Right, well, instead we'll look for 32 in here somewhere. Check shift left and right, okay, well now I've got to ask myself, did I fuck something up by group renaming everything? Well, I guess we'll find out. So what it doesn't like there, oh, don't run that. Right, this is the actual game. We want to go here and go, hey, can you check again and be like, did I fix it by like removing this? I got to go back to the GitHub and check what the hell this was, because I've apparently discovered that batch renaming stuff is not a good idea. Also, the stream's going to end in maybe 15 more minutes because as I said, I got to go out, which annoyingly I was hoping to have made more progress than this. So we're going to go GreedyMesh binary plane, which we are in the GreedyMesh optimized function, which was okay. Then we need to find the function that's called GreedyMesh binary plane, not greedy. I just call it mesh. There's only 10 of them apparently, so there. And then so somewhere you take in LOD size. Wait, what? It's not even. How did I manage to do? Right. Okay, so we define that. So it's where y less than 32, where y greater than or equal to 32. That should all still work. Because I'm pretty sure I replaced it because like LOD size was just a was 32. So raw w less than. So let's use it. Okay, so it doesn't like whatever the hell this is. Function defined, result defined. I'm doing something terribly wrong because I've obviously renamed something to something. So first off, you don't take in a LOD anymore. Now, maybe if I run with you, you'll tell me where it was broken, because this just is throwing so much of an error. So you don't like that add voxel to axis column. So first off, you're adding +1, which I'm assuming by adding +1, this is skipping the padding, which we don't want to do. So then we get chunk.voxels I, which doesn't exist because I think it's so for chunk in chunkref.chunk vex3 to index, that should be fine. Except we want index wait, what? So in a chunk voxel, so chunk ref, so this is 111 is the middle chunk, so this doesn't exist anymore, so this is just chunk. And then it's not called voxels, I don't think, so no. This is apparently called chunk reference. If you got that, you go chunk. Okay, then we get chunk. Okay, so then we should be able to go here, and we go here and go, what did I call it? It says blocks. Can we make this public just so that I don't have to fuck around with this, trying to fix refactor other pieces of my code. So then we go down here and we just say, all right, I'm passing in 32 here, which is fine. So we do this and then we go somewhere. We find this, we can go, so it's chunk.blocks.length, which is chunk size 32 chunk size. So then again, you wait. Oh, did you do that? Wait, what? No. Blocks. .len, and then so this is iterating through all of that, and then we go I match length, right, and then you say I, and then you say add birthday. So this is okay. So that's chunk voxels chunk. Okay, add, and so it's blocks. Okay, and then add voxel to axes, which takes in. Which hilariously might actually be in the right location, not quite. Where did right, no, you just take in a I guess you take in a T, and then we say T implements block type. Right. And then we say B dot is solid. Right. So somewhere we call GreedyMesh.get block. Okay, and then I'm assuming axis AOE voxel pause. Okay. I don't know what this is doing. I feel like I need to is there a, so there's a build chunk mesh, and is there a build chunk mesh without ambient occlusion? It doesn't appear to be. So I need to work out how this works exactly. So get chunk block no neighbor. At current voxel equal chunk. Not. Okay, so we have to go back here. We have to go inside of our chunk. We've got get block. No, that's apparently not located there. Where would that be? Chunk. Chunk ref? Is that where we are? No. Chunk mesh? No, obviously not in chunk mesh. So chunk ref contains chunk data somewhere. So we need to be in. Oh, it's in chunk and then there's chunk data. Wait. Then where the hell are we getting this get block no neighbor from? Where are we setting this chunk? What type is this chunk? Okay, so this is blocks, and then it's still the same chunk. Like I assume it's same chunk, same chunk, same chunk. And then you come down here and you say, hey, this is the same chunk. Right. So how the hell is there a function on this chunk that doesn't actually exist? What? Do I just search the repository for it then? The hell? Yeah, get block no neighbor, which takes in an IVEC2 and says chunk, and then this reference to self.chunks13. Let I equal from index position, comma 32. Okay. Chunk data dot get block. I don't know why it is what? How are you storing these in such a way that you need a 32? I'm assuming that means that like every block contains 32 values or something. That seems a bit obsessive. Okay. So this contains a vector of chunk data, which means that for whatever reason you're storing like 32 chunks worth of data or something. Like, why are we getting 32? That's what I'm not getting. Like, just to show the piece of code that I'm trying to decipher here is we get chunk no neighbors, which then says like chunk data, which means that this is implemented on something. It's on chunk refs. Okay, so then we get the 13th chunk, which by my guess implies that the 13th chunk is the center chunk. So that means there's 9. That's odd. Why are you getting access to chunks that you don't need? Anyway, so there's 9, 10, 11, 12, 13. Yeah, so 13 would be the center chunk. And then we say vec3y index, which is then index 32. So it implies, well, we should probably find out what, doesn't work in the web. This bounds. Oh, okay. Bounds. Right. So it's get it with the bounds of 32. Right. That's easy enough. So get block, no neighbor is just get block ID. So then we check to see if you're sum, I'm guessing. Like, what do you mean? Okay. So this voxel position, which is an IVEC32. So we want to say, get block ID. All right, I've changed all this code how it works. We want to get, yeah, we just want to say blocks. Get index. Oh, right. So we call this and we say get like block. No. Okay. Can I not access your blocks? That seems a bit odd. Oh, I can. Okay, and then by this, and we say chunk data index get index. Oh, it's a bit more confusing. Okay. We say let index equal chunk dot get index, what's it, voxel pos dot x, voxel pos dot y, and voxel pos dot z, and then we go blocks, and we say index. So current voxel, and then something, let current voxel equal current get block voxel position. We can only greedy mesh same block types plus same ambient occlusion. So we say block hash is equal to ambient occlusion index stored with current block type. So can we just say block hash is equal to current voxel dot 0. It's probably going to yell at me because that's not AU32. It's U32. Okay. So I don't know how we got the ambient occlusion. We'll work that out later. So then we say block, and then entry block hash or default entry Y, or default data is Z and X shifted Z. Okay, cool. And then so index, so the ambient occlusion, which is AI index, which is adjacent to direction. So we'll just cut this out because we don't want to do ambient occlusion right now. And then we get the voxel position based off axes. While column is not equal to 0. When do we set column? So we say skip padding, right? Then we say remove the rightmost padding value because it's invalid, and remove the leftmost padding value because it's invalid. So we don't want to do that because we're not doing padding. And then we say while column is not equal to 0, y column trailing zeros, column end equals column minus 1, get the voxel position based on the axes. Okay, and then we say index, and we say this, and we do this, and we or equals this, and then that might be better. See if it even compiles. No, it's still got like 8 errors to go. So get index doesn't work because it wants U32s as U32. I'm running out of time, so I don't even know if I'll get it to compile as U32, which is depressing. I really want to get it to just to the level that it will compile. So technically, okay, axes columns, which wait, what? An array with size 30, but found one with size. Okay, so where did you come from, and why did we declare you as size of? Wait, we called you chunk size, chunk size, chunk size, chunk size. Oh, you're saying that this expects one with a bigger size because these are 34, which actually we want to go 32, which means that something in here is going to need to be changed because that's going to be iterating the wrong number. No, actually it's not. Weird. Right. So we just say axis column. So 0, 1, 2. Okay, so then we got 3 errors to go. So you're saying that block I, the trait block ID is not implemented for. Wait, you get a reference to T. I need to go change your API to being T, where T is block, and then you don't return this. You are a vector of T. And then annoyingly, we need to say like T default. I implemented all this on a different branch, is why I'm getting confused here. We need to say that T also needs to be default, like so. And then this is going to obviously throw a whole bunch of extra issues because we need to import T where T is default and T is block, and then we say here, and we say you just take in fucking T, and then we go, how's that gonna run? Horribly. It's complaining about everywhere not having a T. Can I just find this and say that by default you equal? No, I can't, because block types come somewhere else completely. It's a different crate entirely. God damn it. Alright, okay, here we say chunk T on remove T, which is just going to be up the top. Hopefully, yeah, everything's in like a single implementation block, which means it should all be fine. So yeah, your chunk T. What about you? T. So you return. Yeah. Alright, well, that's going to be the end of the stream because I have to go. This needs to implement block plus default. And then you are R, and then you are R. Okay. And then we run this and we go, there is a lot of errors still to go. Okay, so cannot be shared safely because we need to save a T. Also, we don't want to put it there. Okay. I have got to go. Hopefully you enjoyed the stream. For what I did implement, I will the chunk is filled with yeah. Anyway, so I'll continue implementing this another time. I might do a bit of it off stream until I get to at least compiling and like rendering the chunk, and then we'll work on actually implementing my changes after that. But thank you all for tuning in. It was good to see that you were here, TanTan. I hope you don't mind me bastardizing your code, but we'll see if it makes it faster.
I'm going out.